On this next one, we have a spring, and and we've got a weight attached to it again. And so we have our spring, and it's going to be pulled down 2 inches below the resting point. So we've got our resting point, which is again the x-axis. And then it was pulled down an extra 2 inches. So here it is down at the bottom, sitting here at 2 inches. Now what? Assuming the period is 1/3 second, determine a model that gives the position of the weight after t seconds. So they're saying this in a really fancy way, but they're asking for the equation, is what they're doing. So what we'll go do is we'll use D equals, because we're starting at something that's not 0, 0, we're starting at the bottom, we are definitely using cosine. And we don't know omega, we leave t alone always. And because we're starting down at the bottom at a -2, meaning it's been pulled down, our cosine, our number in front of the cosine, our a, will be a -2 as well. The problem is going to be finding the omega, but we've already done that before, so it shouldn't be too bad. So let's find omega using the period. So we have that we know that the period is 2 pi over b, or omega in this case. And we'll go ahead and fill that in. We know that the period is, let's see, from the problem, if we go back up, 1/3 second. So we can go ahead and pull that and put that in 1/3 second. We've got our 2 pi, and we do not know omega. We're going to try and find that. So we have 1/3 equals 2 pi over omega. To solve this for omega, we cannot leave omega in the bottom, so we need to multiply both sides by omega. That will get us, let's see, a 1/3 omega equals 2 pi. Now to get rid of the 1/3, we're going to do the reverse. We're going to multiply both sides by 3. And then that does leave us with a 1 omega, which is just omega on the left, and then the 2 pi times the 3 on the other side gives us a 6 pi for our omega. And now all we have to do is plug in our omega back into our formula that we came up with, or our equation that we came up with, which is now going to be D equals -2 cosine. We just found out omega was 6 pi, and then we have our T. And that's our final answer for what they were asking for. I know the wording was strange, that they said determine a model, but whenever they're talking about a model, they just mean it's a fancy way of asking for the equation. Last part here, they want the frequency. Well, remember the frequency is the reciprocal of the period. So what was the period that they gave us? Remember, the frequency is 1 over the period, or the reciprocal of the period, and the period was 1/3. So the frequency should be the reciprocal of that, 3 over 1, which is 3. And remember, the frequency, the units of that is in oscillations per whatever unit of time we have, which in this one, if we go back up, the unit of time is still in seconds, so this will be 3 oscillations per second. And that's our final answer.